Welcome to Pharma Center. Today we are going to see a detailed view about acids, bases and buffers. If you are not subscribed this channel, please subscribe it. Topics to be covered in this chapter is traditional concept, Arrhenius theory, Bronsted-Lowry concept, Lewis theory, and a detailed explanation about boric acid, hydrochloric acid, strong ammonium hydroxide, sodium hydroxide, buffer solution, official buffers and standard buffer solution. Now coming to four main theories. Acids and bases are defined by four main theories. First theory, traditional theory or concept. Second theory, Arrhenius theory. Third theory, Bronsted and Lowry theory. Fourth theory, Lewis theory. Now coming to traditional theory or concept. According to traditional theory, acids are the substances which converts blue litmus paper to red, and it has the pH less than 7, and the acids are sour in taste. Reacts with bases to form salts and water. Example, hydrochloric acid. Now coming to bases. According to traditional concept, bases are the substance which converts red litmus paper to blue, and bases have the pH greater than 7, and bases are bitter in taste. Bases react with acids to form salt and water. Example, sodium hydroxide. Now coming to Arrhenius theory. According to Arrhenius theory, acid is a substance that can release hydrogen ion when dissolves in water. So hydrochloric acid, when dissolves in water, it releases hydrogen ions and chloride ions. Next, base. According to Arrhenius theory, a base is a substance that can release a hydroxyl ion when dissolved in water. When sodium hydroxide dissolved in water, it releases sodium ions and hydroxyl ion. Now coming to Bronsted-Lowry theory. An acid is a substance that denotes protons. So acids are proton donor and bases are proton acceptor. So a base is a substance that accepts protons. Now coming to Lewis theory. According to Lewis theory, acids accepts electron pair and bases donates electron pair. So these are the four main concepts that gives an explanation about definition of acids and bases. Now coming to boric acid, the synonym of boric acid includes orthoboric acid and acidium boricum. Molecular weight of boric acid is 61.83 gram per mole. Preparation of boric acid. Boric acid is prepared when borax with sulfuric acid in the presence of water. So this is the equation for the preparation of boric acid, in which borax reacts with sulfuric acid and water and boric acid will be formed. Now coming to properties of boric acid. Physical properties of boric acid includes white crystalline powder, odorless, it is soluble in water and soluble in ethanol and soluble in glycerin. Now coming to chemical properties. Boric acid on reaction with turmeric paper, that is boric acid turn into a brown color when it reacts with turmeric paper. And reaction with glycerin. Boric acid reacts with glycerin and it gets dissolved in glycerin and it forms glyceroboric acid. Then boric acid on action on heating. So boric acid on heating forms metaboric acid, and further heating it forms tetraboric acid, and tetraboric acid on further heating it forms a boron trioxide. So this is a chemical properties of boric acid. Now coming to uses of boric acid. So boric acid is used as a local anti-infective and to maintain acidic pH medium in medicament, and in the preparation of a buffer solution and in ophthalmic preparation, boric acid is used as dusting powder and in the preparation of ointments. So that's all about boric acid, and storage of boric acid includes it should be stored in well closed container at a cool place. Now coming to a next drug, that is hydrochloric acid. Next acid, that is hydrochloric acid. Synonym for hydrochloric acid is spirit of salt, muriatic acid, acidium hydrochloricum. And molecular weight of hydrochloric acid includes 36.46 gram per mole. And preparation: concentrated sulfuric acid react with sodium chloride to form hydrochloric acid. So this is the equation in which a sodium chloride reacts with concentrated sulfuric acid to form hydrochloric acid. This is very important compound. Now coming to properties of hydrochloric acid. Physical properties includes it's a clear colorless liquid and it has pungent odor. It is miscible with water, miscible with alcohol, and it is a fuming liquid. Now coming to chemical properties. Hydrochloric acid on reaction with metals. Hydrochloric acid react with sodium gives sodium chloride and evaluation of hydrogen gas. So this is the equation in which two molecules of sodium reacts with the two molecules of hydrochloric acid to form two molecules of sodium chloride and hydrogen gas. Hydrogen gas will be evolved. And reaction with alkali. Hydrochloric acid on reaction with alkali. Hydrochloric acid reacts with sodium hydroxide, which is alkali, gives sodium chloride and water. This is the equation in which hydrochloric acid reacts with sodium hydroxide and it forms sodium chloride and water. Now coming to uses of hydrochloric acid, it is used as a pharmaceutical aid, that is used as an acidifying agent, and it is used as a solvent in industry and for manufacture of basic pharmaceuticals and reagent in laboratory. Storage of hydrochloric acid. It should be stored in a well closed container of glass at a temperature not exceeding 30 degrees Celsius. So this is a very important compound in chemistry. Now coming to a next compound, strong ammonium hydroxide. The formula for strong ammonium hydroxide is NH4OH. Synonym: ammonium solution, ammonium hydroxide, strong ammonium water, and liquor ammonia fortis. Coming to molecular weight, 17.03 gram per mole. Preparation of strong ammonium hydroxide. It is prepared by mixing ammonium chloride with slaked lime. So this is the equation in which ammonium chloride is mixed with calcium hydroxide, which is also known as slaked lime, to form ammonium hydroxide and calcium chloride. Now coming to properties of strong ammonium hydroxide. First, physical properties. It is a clear colorless liquid and it has a pungent odor, characteristic taste, miscible with water, and it is an aqueous solution and is strongly alkaline in nature. Now coming to chemical properties. Strong ammonium hydroxide on reaction with acid, it forms salt and water. This is the equation in which ammonium hydroxide reacts with hydrochloric acid to form ammonium chloride and water. Next, reaction with cations. On reaction of strong ammonium chloride with cations, it forms a complex. Now coming to uses of strong ammonium hydroxide. It is used as an alkalizing agent and reflux stimulant, that is it is used as a reflux stimulant for fainted person, vasoconstrictor, strong base, antacid, and it is used as a reagent in laboratory. Now coming to a storage of strong ammonium hydroxide. It should be stored in well closed amber colored container with a rubber stopper at a cool place. So incompatibility, it is incompatible with iodine, heavy metal, silver salts and tannins. With iodine, it acts as an explosive compound. Now coming to a next compound, sodium hydroxide. Molecular formula for sodium hydroxide is NaOH, and synonym for sodium hydroxide, caustic soda and soda lye. The molecular weight of sodium hydroxide is 40 gram per mole. Preparation of sodium hydroxide. It is prepared by treating sodium carbonate with lime water. This is the equation in which a sodium carbonate reacts with lime water. It forms sodium hydroxide and calcium carbonate. Now coming to a physical properties. It is a white amorphous pellets and it is slight bitter taste, soluble in water and soluble in alcohol. And it is also soluble in glycerine and it is deliquescent in nature. Now coming to a chemical properties, sodium hydroxide on reaction with hydrochloric acid and on reaction with carbon dioxide. First, reaction with hydrochloric acid. Sodium hydroxide react with hydrochloric acid gives sodium chloride and water. This is the equation. And on reaction with carbon dioxide from air to form sodium carbonate, in which two molecules of sodium hydroxide reacts with carbon dioxide to form sodium carbonate and water. This is the equation. At last, uses and storage of sodium hydroxide. Sodium hydroxide is used as alkalizing agent and as disinfectant for animal houses and for preparation of soap, and it absorbs carbon dioxide gases from air, and it is used as a common laboratory reagent. Now storage of sodium hydroxide compound. It should be stored in an airtight container at a cool place. Next main topic is buffer solutions. A buffer solution is one which maintains its pH fairly constant even upon the addition of small amount of acids or bases. There are two types of buffer solution. One is acidic buffer and another one is basic buffer. We can see a detailed explanation of these two buffers. First one, acidic buffer. It is a solution of a mixture of a weak acid and a salt of this weak acid with a strong base. So acetic acid is a weak acid and it is a mixture of weak acid and a salt of weak acid. So it is a mixture of acetic acid and its salt, that is sodium acetate. Now coming to a basic buffers. It is a solution of a mixture of weak base and a salt of this weak base with a strong acid. So ammonium hydroxide is a weak base and it is mixture of this weak base and a salt of this weak base, which is a ammonium chloride. So this is basic buffer. Now coming to a next main topic, official buffers. So these are the buffer solutions recommended by pharmacopoeia are called as official buffers. We can see four main examples for official buffers. First one is acid phthalate buffer. Second one is alkaline borate buffer. Third one is phosphate buffer. And last fourth one is acetate buffer. First one, acid phthalate buffer. It contains potassium hydrogen phthalate and hydrochloric acid. Second one, alkaline borate buffer. It contains boric acid, potassium chloride and sodium hydroxide. Now third one, phosphate buffer. It contains potassium dihydrogen phosphate and sodium hydroxide. And fourth official buffer is acetate buffer. It has a pH 2.8. It contains sodium acetate and glacial acetic acid. Now coming to next topic, standard buffer solutions. So standard buffer solutions or solutions of standard pH. Now coming to Henderson Hasselbalch equation, it is one of the very important equation. So for weak acid, the Henderson Hasselbalch equation includes pH is equal to pKa, which is a dissociation constant. pKa is a dissociation constant plus log of conjugate base divided by weak acid. And Henderson Hasselbalch equation for weak base includes POH is equal to pKb plus log of conjugate acid divided by weak base. Now uses of buffers. So pH of the blood is maintained by the buffer system present in our body. So buffer is used in cosmetics and it is used for wine making, and pH balanced shampoos and deodorants are mainly used because of buffers, and it is used in the calibration of pH meter. If you like this video, press like button and share to your friends. Thank you.